A lesson on derivations. When we derive something, that means that we're going to create a new equation from previous equations. And so, in a previous lesson, we had all of these equations. Some of them we saw before, but some of them are brand new, and I never really said how we got them. It's important for you guys to know that these equations did not come floating down from the clouds on a golden plate with loud trumpets blaring and bright sunbeams, but they were derived from other earlier ideas. So let's go through this. And in your note packet, you have a big empty spot on your page. Would you please divide that up into 3 sections? And that will help you to space out your notes today so you can fit everything onto this one page. In box number 1, we're going to start off with 2 equations for average velocity. The first one is what we had for lesson 1. The second equation for average velocity looks an awful lot like taking an average of any 2 numbers. You add them together and divide by 2. So in this case, we're taking the initial velocity, adding to the final velocity, and divide by 2. This works if you have a steady acceleration between those 2 velocities. I can rewrite this just a little bit by not making it a fraction. Instead of dividing by 2, I can multiply by 1/2, and it's the same idea. Okay, so we have 2 equations now for the average velocity. Let's put them together into one equation. And then I'm going to multiply both sides by t. And I get this. And that, ladies and gentlemen, is equation 4a. Now, on the left-hand side here, we have this triangle x, the delta x, and we can rewrite that as the final minus the initial locations. And that's equation 4b. That's the end of box number 1. We're going to move on to box number 2, and we're going to start off with this equation right here. You don't have to rewrite it, but just keep that in mind. Okay, in box number 2, we're going to start off with this acceleration equaling the final velocity minus the initial velocity divided by time. We had that from a previous lesson. And we're going to multiply both sides by t in order to move that over to the other side. And we get AT equals VF minus VI. Then we're going to add V1 to both sides to move it to the left. And we end up with AT plus VI equals VF. And just to make things look kind of pretty, we're going to switch the sides around. And we get VF equals VI plus AT. That, ladies and gentlemen, is equation 1c on your list. We're going to use this equation 1c with our boxed equation up here. Let me think, that was equation 4. And we're going to substitute in the VI plus AT in for this VF. Since this box is equal to VF down here, we can substitute it up there. And we get this equation. Now notice that the delta x is the same, and the 1/2 is the same, and the V1 and the t. It's just this VF that has been changed to be the V1 plus AT. Okay, now the next thing we're going to do is put these V1s together, and so we get 2V1. The next thing we're going to do is to multiply through the parentheses by the t. And we get this. And then we're going to multiply through by 1/2. We get that. Now let's look at the delta x. Once again, we're going to expand that to be x sub f minus x sub I. And the right-hand side stays the same. Then we move the x sub I to the other side by adding it to both sides. And we get equation 2. X sub f equals x sub I plus VIT plus 1/2 AT squared. That, by the way, is my favorite equation. Yes, I'm a science geek. I have a favorite equation. This is probably the longest equation that I learned in high school physics, and I just kind of liked it because I understood all the different parts. It made sense, and I won't get into it anymore. Anyway, here we go. Box number 3. We're going to start off with the equation we had from box 1 of your notes, and this equation here that we also had previously. Now, with this box, we can rearrange this, we can solve for t, and we get this fraction. To do that, we multiply both sides by 2, and then we divide by VF plus VI, get that on the bottom. So once we have this equation for t, we can substitute it into the other equation for t, and we get this. Notice that the VF is the same, the VI is the same, the A is the same. It's just that the t has been changed to this fraction. And now I'm going to move the A to be on the top of the fraction. And we get this. Next, I'm going to move the VI to the other side by subtracting. And then I'm going to get rid of this fraction, and I do that by multiplying both sides by VF plus VI. And I get this. Now notice on the left-hand side we have two binomials multiplied together, and so I'm going to multiply those together by using FOIL. First, outside, inside, last. Two of the terms are going to cancel out, and on the left-hand side we're left over with VF squared minus VI squared equals 2a delta x. Next, I'm going to take the VI squared and move it to the other side by adding it to both sides, and I get this, and that is equation 3a. And that's the end of the lesson.